In this lesson, we're going to talk about a whole bunch of different types of functions and give some information about them. And we'll also talk about piecewise defined functions. So first here, our first two pages, we're going to determine whether the function is even, odd, or neither, and state whether the graph of f is symmetric with respect, this should say, to the y-axis, the origin, or neither. We're going to find any intercepts. We're going to look at the graph of the function. I'm just going to use Desmos because I already have them typed in to save some time, and state the domain and range. So I have the notes filled out again already here, so feel free to pause if you need to pause them. But really, we're going to check the graph out first and kind of analyze the graph. So first we have the constant function, which is f of x equals b. Looking at that graph, it's just your horizontal line, and b can be any real number, so it really doesn't matter. My graph here is just going from 10 to negative 10 to show that. But if you kind of look at it, it has symmetry with respect to the y-axis, which means it's even. It does have a y-intercept at whatever the b value is, and its domain is any real number, and its range is the set of whatever value of b is. So that's shown here. Your y-intercept is 0, comma b, and then your range is the set consisting of a single number b. The identity function is f of x equals x. So looking at that, we have here, so we do have a y-intercept of 0, 0. It is symmetric with respect to the origin, so that means it's an odd function. Our domain and range is any real number. Next, we have the square function, so f of x equals x squared. You should know that that's a parabola. We do have an intercept there of 0, 0. It is symmetric on both sides of the y-axis. So it's even, symmetric with respect to the y-axis, has an intercept at 0, 0. Its domain is negative infinity to positive infinity. And its range, the smallest y value was 0, and that was included, so 0 to infinity. Our cube function, f of x equals x cubed, looks like this. We do have an intercept at 0, 0. It is symmetric with respect to the origin. Our domain and range are all real numbers. So that is for the cube function. Notice how when my power of my function is odd, it's been an odd function so far, and the power of if my power is even, it's been an even function. Next we have the square root function. So when graphed on Desmos, it looks like this. There is an intercept at 0, 0, no symmetry. Our domain, notice our graph is only in the first quadrant. So our domain is all x values greater than or equal to 0, so 0 to infinity, and our range would be the same. And that's listed there. Moving on to the ones on the back, we're doing the same thing. Cube root function, looking at its graph, looks like this. It does have an intercept at 0, 0. It is symmetric with respect to the origin, so it is an odd function. So odd function, its domain and range are both all real numbers. The reciprocal function, f of x equals 1 over x, looks like this. Okay, notice as we zoom in, we're not crossing any of the axes, and that's because x is in the denominator, so we cannot divide by 0. So x will never be 0, which means there's a 1 on top, so there's no way that y could also ever be 0. So that was symmetric with respect to the origin, so it's odd, no intercepts, and the domain and range are all non-zero real numbers. The absolute value function makes a V shape, so it is symmetric with respect to the y-axis, so it's even. It does have a y-intercept at 0, 0. And its domain is all real numbers, so you can plug in any x value, but our range, it turned at 0, 0, so our range is from 0 to infinity. And then next we have the greatest integer function. In a TI-84 calculator, you can use INT in your menu. For this, we use floor and Desmos. Now, I do want to point out, I can't really draw on this here. So the right end of each step, sometimes this is called a step function, the right end of each step, like where I am now, actually is an open circle there. So it's not quite showing it, but what it does is it jumps to the next integer. So -2, -2, -2 for your y value, jumps -1, -1, -1, and so on. So it keeps doing that. You notice we do have an intercept at 0, 0, and on the interval 0 to 1 are also intercepts. So I've drawn here what it typically normally would look like. It has that open circle there because it wouldn't be a function if it was defined if that x value had 2 y values. So no symmetry, so it's neither odd or even. Intercepts on the interval 0 to 1, not including 1, and at 0, 0. Our domain is negative infinity to positive infinity. Excuse me. And our range is all real numbers y such that y is an integer. Okay, so notice y was only integers there. Okay, talking about piecewise defined functions here. So when a function is defined by different equations on different parts of its domain, it's called a piecewise defined function. So here we have f of x equals -2x if x is less than 0, and the square root of x if x is greater than 0. So first we're asked to find f of -4, f of 0, and f of 4. So f of -4, we're going to use this first equation because x is less than 0, so that's the one we need to use. So we're going to take -2 times -4, which is 8. So f of -4 is 8. F of 0, we're going to use our second equation because when x is greater than or equal to 0, we use this one. So we're going to use the square root of 0, which is 0. And then last, f of 4, we're going to use the second equation because it's greater than 0. So f of 4 equals the square root of 4, which is 2. Part B says find the domain. I'm going to do that up here. The domain is the union of the domain of each of those equations. So first here, my domain is from -infinity to 0, not including 0. And union with, for my second equation, my domain is including 0 all the way up to infinity. So if you notice there's no jumps here, we go from -infinity to 0, and then 0 is included all the way up to infinity. So our domain really is -infinity to positive infinity. It asks us to locate any intercepts. So the y-intercept would be when x is 0. So when x is 0, we have to use this one, the square root of x. And we already actually did that. F of 0 was 0. So there's an intercept at 0, 0. And you could always look at the graph for that too. So next we're going to graph it. So let's make sure 0, 0 is our only intercept. Looking at the graph here, this is what that graph looks like. So the red shows the first part of the domain, and then the blue is the second part. So there is an intercept at 0, 0, and it looks like that is the only one. Okay, so that's what our graph looks like. When you're typing that into your calculator, you would just put in y equals negative 2x, do your division with parentheses, x is less than 0, parentheses. And then in y2, you would enter the second one the same way. So we graph this in Desmos. And then use the graph to find the range. Well, the range, if you notice our smallest y value, it never goes below 0. So our range is from 0 to positive infinity, including 0. All right. Next here, another one. We have 3 different ones here. So we use the function is defined as negative 2x plus 1 if x is greater than or equal to negative 3, but less than 1. If x is 1, then the function is defined at 2. And if x is greater than 1, we use x squared. So finding f of negative 2, negative 2 means we're going to use the first equation here because it falls within this domain. So we're going to take negative 2 times negative 2 plus 1, which is 5. F of 1, well, when x is 1, the function is valued at 2. So f of 1 equals 2. And f of 2, we're going to use this here. So 2 squared is 4. So f of 2 is 4. Okay, finding the domain, the same thing. We're going to have to use the union of the 3 different domains. So our first one ranges from negative 3 to positive 1. 1 is not included. In union with the second domain is just the set number 1. In union with our third domain here for x squared if x is greater than 1. So we do not include 1, and it goes to positive infinity. Again, if you kind of look, we don't have any jumps. We go from negative 3 to 1, and then 1's included, and then we go from 1 all the way up to infinity. So our domain is negative 3 to infinity with negative 3 included. Okay, locating any intercepts. If we want x to equal 0 to find the y-intercept, x equaling 0 is in our first equation here. So we're going to use negative 2x plus 1 because x equals 0 is part of that 1. Okay, so we're going to do f of 0 equals negative 2 times 0 plus 1, and 0 plus 1, which is 1. So 0, 1 is an intercept. And then again, I also like to just check the graph. There might be another one. There could be an x-intercept. So when the y is 0, what does x equal here? So looking at my graph, there's the first part of it. Second part's just an ordered pair. And then there is my third part. So notice we do have an x-intercept here. So there's our y-intercept of 0, 1. Our x-intercept is 1/2, 0. Okay, so if I take 0 equals negative 2x plus 1, subtract 1, divided by negative 2, you get x equals 1/2. So it is true for this one when y is 0, x is 1/2. If I tried it for this one, if I did 0 equals x squared, I would get x is 0. But x is 0 is not defined in that interval. So that's not possible. We can't do that. I just showed you the graph, but just to go back and look at it, and we'll talk about the range. Okay, so when I get down to the bottom here, it does say 1, and then the y value is undefined because that's because when x is 1, our ordered pair there is at 2. Okay, right there, 1, 2. So our range then, our smallest y value is -1, but it's undefined at -1, so we'll use a parentheses around that. So it goes from -1 to infinity. And then moving on to our application here, we're going to write the piecewise defined function. In spring of 2018, Duke Energy Progress supplied electricity to residences in South Carolina for a monthly customer charge of $8.29 plus 8.6035 cents per kilowatt hour for the first 1,000 kilowatts supplied in the month, and 9.1446 cents per kilowatt hour for all usage over 1,000 kilowatts in the month. So part A just asks, what is the charge for using 500 kilowatts in a month? Well, for up to 1,000, we pay $8.29 plus 8.6 cents per kilowatt hour. So we're going to pay the $8.29 plus, now be careful, it tells us, and the wording says 8.6 cents. We got to go back 2 decimal places. So 0.086035 per kilowatt hour. So we're going to multiply by 500. And when you plug that into your calculator, you get a total cost of $51.31. Part B, what is the charge for using 1,500 kilowatts in a month? Well, for the first 1,000, we pay the $8.29 plus 8.6 cents. Then for the next 500 over the 1,000, we have to pay the 9.1 cents. So we pay the $8.29 plus 0.086035 times 1,000 plus 0.091446 times 500. You do that math and you get $140.05. Part C here, if C is the monthly charge for X kilowatt hours, develop a model relating the monthly charge and kilowatt hours used. That is, express C as a function of X. Okay, so now we're writing the model for the function. So we just said from 0 to 1,000 kilowatt hours, we pay the $8.29 plus the 0.086035 per kilowatt hour, which is represented by X. For more than 1,000 kilowatts, we just said you pay the $8.29 plus you pay the 0.086035 times 1,000 because we know for a fact we've used 1,000 already, plus 0.091446 times, now we're not just going to put X here, so X is representing the kilowatt hours used. But we just already said we know we've used 1,000 of them if we're talking about the part where there's more than 1,000. So what goes here is going to be X minus 1,000. So we need to take away the 1,000 we've already accounted for. So we got to clean that up. We got 8.29 plus 86.035 plus 0.091446x minus 91.446. Combine your like terms. we end up with 0.091446x plus 2.879. So when we rewrite our function here, we have c of x equals, we're going to use, I'm going to write this in slope-intercept form, the 0.086035x plus 8.29 if x is between 0 and 1,000. And yes, I included the 0 because even if we're not using a kilowatt per hour, we're paying for the service of $8.29. So, and then my other one would be 0.091446x plus 2.879 if x is greater than 1,000. Oops. No. And there would be our model that represents how much you would pay monthly.